Just to clarify, this is our community call, and like a few community calls ago, we want to experiment with our format. And a couple of months ago, the voice lunch community in Russia invited me to give a talk about our experience with Alexa Prize 3 from product perspective, as well as to share what we learned and what might be the good direction for developing a social bot for like an open domain dialog system. And this dialog system is actually something that is painful to build. And it is an extraordinary journey that our lab is going through since 2019. I think I would be happy if someone would assist me in bringing people aboard. Misha, can I ask you to be a co-host for the time being?
No. Ask Vasily.
Vasily, can I ask you to do that? All I actually need is someone to also admit people into the event. I know whom I probably can also rely upon is Niklas, one of our bright research students of this year. Niklas, can I rely upon you?
What do you need me for? Sorry.
Sure. Look, so there will be more people coming up or coming here in the next maybe 5 to 10 minutes, maybe more.
All right.
It would be helpful if you would just, accept them, admit them into the event.
Yeah, of course I can do that. No worries.
Thank you very much.
Sure.
Okay, so it's 7:10 p.m. and I think we are getting started. So just to clarify, this is a slide deck that is a little bit updated and a little bit different from the one I presented back in September, I think, of the last year, while we were working on our application for Alexa Prize 4. So for some of the members, a small number of people here from Alexa Prize 4 team, they already have seen the early version of the slide deck. But for the rest of you, this is something new. And given that Alexa Prize 4 is more or less coming to its conclusion later this summer, I thought it would be interesting to look back and take a look at what we actually have learned from working in the field. And before we'll get started, back in last year, somewhere around May or June, I believe, we had a talk about the vision of a functional model of an AI assistant. And since the moment, that very moment, as a product guy in a lab, I tried to focus our different work areas, our entire direction towards building components, parts of that vision. And it's a definitely multi-year kind of thing. And it's something that involves bringing a lot of incredible talent from Russia and from all the other countries in the world. It's extremely humbling for me to see here, for example, Lydia, who joined us and helped us with speech function classifier. I'm fascinated to see Niklas, who joined us as one of our Google Summer of Code students. And while there are no people here, no other folks here yet, like Alek and others, I'm deeply grateful for everyone who joined us since last summer and who helps us to move forward with our vision for building AI assistants of the next generation. And I want to start with a quick reminder what the whole XPRIZE challenge is all about. It is a big challenge, and it could be called as a holy grail of our industry. We need to build a social bot that can engage in a fun and high quality conversation for 20 minutes. And we need to achieve an average rating of at least 4 out of 5. And this is a really big challenge. In the last year, and that was at XPRIZE 3, the winner managed to achieve almost 4 points out of 5 in the rating, but they only managed to achieve a meaningful and engaging conversation for 7 minutes and 32 seconds before the judges. And it says a lot about just how complicated it is to build a social bot that can talk on a variety of different topics. And we also participated in the thing in 2019, 2020, and second time this time. And I think we've learned many things. Some of them I would like to share with you. And I want to start with the architecture of the dialog management in this kind of social bots and in multi-skill AI systems in general. I had a chance to work on Yandex Alice, which is a Russian AI assistant, but also later on I had a chance to build some skills for Amazon Alexa, and in general they all look the same. You have a user query, or you have a user utterance, if you like, and there is a dialog management system that decides which part of the dialog system has to actually process the user's utterance. And in commercially available AI assistants, it usually falls into one of the 3 areas. You start either with our own scenarios and maybe some third-party integrations like calendar and notifications like reminders and tasks and many other things. You have third-party integrations like switching on or off a home assistant components and so on. That's like a bracket number 1. The bracket number 2 is search. And this is a very important thing, is search allows you to actually make a fallback. When you don't know what you can say to the user, you can always fall back to search, which obviously is not the best user experience you can provide to the user, but it's better than saying nothing. And then finally, you have the third-party skills that allow AI assistant to expand amount of things that is capable of doing, and doing that by allowing third-party developers to actually build their own skills that extend the whole thing. And there's obviously one more component at Yandex. It's called Chatter, Boltavka in Russian, and in English it's in Amazon Alexa they have Let's Chat, which is a mechanism allowing users to have an open domain conversation with the social bot, with the AI assistant. And when we were working on Dream Social Bot last year, which was a huge undertaking, converting our Dream Social Bot from XPRIZE 3 into our own mini multi-skill AI assistant, that architecture in a way could be described the same way. We had our own scenarios, and then we added Wikidata and OTQA for like a replacement for search functionality. And because we started this whole thing as a multi-skill AI system platform, we obviously enabled it for building skills into the system like our commercial counterparts. But the biggest difference, and this is where some of the challenges begin to appear, is in Yandex Alice, and Amazon Alexa, and Google Assistant, and others, you usually have to invoke a different skill by its own name, unless it's its own scenario. So if you want to order pizza from Pizza Hut, you have to say, like alias, ask Pizza Hut, and then you work with Pizza Hut. And while you interact with Pizza Hut, you cannot interact with other skills, or you cannot interact with the high-level components. Like you can talk to Pizza Hut, and then you suddenly remember that you need to have a reminder for I don't know, like calling your friends to come to a pizza party. And you cannot do that with Yandex Alice or Amazon Alexa. And this is a huge problem. And in our case, we developed our platform from the day one in such a way where users don't have to know how the architecture of the system is actually looking like. They don't have to know that there are first or third party skills. We wanted to design the whole thing to have a natural user experience so that the user would just say what they want and a particular specific skill would just fire itself up. And the next step in the multi-turn conversation, the next time the different skill might pop up instead because it would be more relevant to the user. And a small heads up from our last year experience, I mean, from the last Alexa Prize, Alexa Prize 4, it turns out that maybe it's not the best idea to switch skills at every single step. And maybe sometimes we have to be more proactive and so on. But in general, this is the only way how you can build a nature user experience. So in a way, those AI assistants that are able to completely remove the need to name the skill, to interact with it, are the next generation of AI assistants. And to the best of our knowledge, only Amazon is trying to work in this direction. And they try to make different skills capable of calling each other transparently to the user, but this is still remains a huge challenge. And that, in a nutshell, one of the reasons why Amazon Alexa Prize Grand Social Bot Challenge exists. Because here, we don't have the way to invoke different skills. We have to find a way to pick the right skill and do it transparently to the user. Now, before I will continue talking here, let me put it this way. Last time I was giving this this presentation, the Voice Lunch Russia, it turns out that the first time it took like 2 hours and we barely scratched the surface. And the second time it took like 3 hours. So my goal for today is not to cover absolutely everything in this slide deck, but cover as much as we can in maybe 1 hour. And then we can continue in the next consequent community calls and continue the conversation and pick up from where we will end today. Okay, so why dialog management is so complex in multi-skill AI systems? In the beginning, we always have to understand what is the goal of the user's utterance. Like we have Alice and bot, and Alice asking what's happening in the city hall, what's happened in the city hall. And when we think about it, and we think how bot has to be designed to properly work with the user's utterance, we obviously ask questions like which city hall, and for that entity's abbreviation can help. Then we have to recognize where exactly that city hall is. That may be New York City, which is famous for its city hall, or something local to the user. It may be some place in Seattle or in Pennsylvania or someone else. It can be also a matter of time. When exactly that happened? Maybe it happened last year, maybe it happened yesterday, maybe it happened today. And there are lots of different other questions that we can potentially ask ourselves within different kinds of user utterances. Now, after we manage to ask those kind of questions without maybe asking the user and trying to get clues from the previous conversation, we need to correctly generate responses. And so, for example, let's imagine that we have 3 different skills. One is new skill, and it can say that Occupy City Hall happened in July 2020, and its confidence is 0.85. Then we have another skill, factoid, which is like our replacement for search, and works on top of a knowledge base. And it says that City Hall is the seat of New York City government. So the confidence is 0.95. And finally, let's imagine we have a retrieval skill, for example, powered by Convert-Ready database. And it says that by 1969, City Hall was described as badly crowded because of belly growing, blah, blah, blah. And confidence is 0.75. Now, the third task that our system has to do on a high-level perspective is to correctly pick the best response. And the problem is, if we will just base ourselves on the confidence of the system, we can end up with this experience. So Alice asks, what happened in the city hall? And the bot will pick the highest confidence response and says, City Hall is the seat of the New York City government. And on one hand side, it makes sense because we picked the answer with the best confidence and we trusted our skills that they know the best. But on the other hand side, we've got an experience which is frustrating because this is obviously not what the user wanted to hear from us. So just merely basing ourselves on the confidence is not sufficient to make the best decision about what we should reply to the user. And as you can see, there also is a lot of questions that we have to ask ourselves and maybe ask user to actually be confident and that our response is relevant to what user actually wanted us to talk about. In our architecture, we designed the system in such a way that we have a skill selector. And that skill selector is a mechanism that allows the system to pick more than one skill to generate response. And inside each of the skills, we may have more than one context to choose from. We have scenario-driven and story-driven skills. And I'm not mentioning generative or retrieval skills, which are a bit more easy or super complicated in their internals. But they might have multiple options to choose from, which is important because some of those skills might generate more than one hypothesis as a response. Then at the response selector, we have, we might end up, and we usually end up with more than one hypothesis to choose from. And as I said before, we cannot be based just on the confidence level to pick the best hypothesis to the user. So here's our architecture, and it starts with a very simple idea that every time user says something, we want to get the hell of information about the user from one simple utterance. So we want to, for example, transform this spoken language into written language by sentence segmentation. Then we want to extract entities that are mentioned by the user. Then we want to see other aspects. We want to know what the sentiment level has been expressed by the user, what emotions are, and maybe if there is some toxicity level. And some users, as we managed to learn from our Alexa Prize experience and from hosting our Dream Social Bot on our website since last September, some people are toxic, and we need to recognize that, and we need to adapt our system to that. Other things that are important are, for example, we need to understand the topic to which users' utterance can be classified to, can be attributed to. We also need to understand what Dialog Act represents users' utterance, and the Dialog Act theory is by itself a huge and specific topic for a separate discussion. We also have intent catcher, which identifies high-level intent that allows the system to respond to some of them and maybe to pick the best skills just based on the intents we identified at the top level. Then we have skill selector, which is also a marvel. It is a rule-based system that is very delicately balanced to pick the best skills that address users' utterance based on all the annotations we collected about this utterance, as well as the previous dialog state that we have in the system. One skill selector picked several skills to generate responses. All those skills start to work in parallel, trying to provide the response based on whatever logic, whatever schemes we have within the system. Finally, we have candidate annotators that help us to understand if you're going to use this response and then lead the conversation to dialog termination, which is something we obviously don't want. And we also want to be sure that if we have a response given to the user, we are not going to say something that is inappropriate. And this is not specific for handcrafted skills, but it is very specific to retrieval skills. And same goes for toxicity. We don't want to be toxic to our user. And we also built a conversational later model that tries to evaluate different perspectives, all of those hypotheses, how could they impact the conversation moving forward. After that, response selector has to pick the best hypothesis, and it is also a very delicate process. We cannot rely on just one of the annotations, and we have to pick a lot of different perspectives in mind to pick the best response. After that, we can apply some post annotators or response annotators that can further enhance or annotate the responses so that those annotations could be picked up in the next turn of our conversation system. And moving forward, our social bot has these three levels: skill selector, skills, and response selector. And this is a foundation for building a social bot or multi-skillia assistant if you want to go beyond just open domain dialog systems. But we obviously had to further extend it for Alexa Prize 4 and for our DP, which is our open source multi-skillia assistant platform. Now that you have the high-level perspective of how we designed our conversational AI orchestrator and how we designed our social bot for Alexa Prize 3, let's talk about some of the lessons that we learned from version 1 of our Dream social bot. So the very first idea that we learned back in March and April of 2020 was that we need to have topics. And this might sound like a very simple idea, but the problem is when you apply topic modeling across traditional documents, you usually have written speech or written language, if you like, and you have a lot of information in the document. So you have a lot of anchors that you can use to model your topics for the document that you have. But when you talk about casual conversation, when you talk about spoken language, topic modeling becomes a tough problem. And it's one of the areas where we decided that we will have to put a lot of our attention in the next version of our social bot. And another big lesson that we understood, and which is still a big part of our design for conversational AI orchestrator, is we need to have this balance between the smart response selector and smart skills. The problem of this balance is very simple. If you believe that your skills are super smart and can completely address all the needs of your user based on whatever information you provided to them through the annotators, then you have to institutionalize a process where you can measure all of those skills and say that their levels of confidence could be actually comparable to each other. But then if you only depend on the smartness of your skills, then you are able to control just islands of meaningful conversation between you, user, and your social bot or your AI assistant. But if you want to control the conversation across the entire spectrum of all topics that you have in your system, you have to control dialogue on a higher level. And this is where your smart response selector comes in. On the other side, if you want to control everything using your response selector down to particular details, then you have to put lots of logic into your response selector. And in this case, your response selector would be super hard to control and super hard to evolve. So in the essence, when you want to build a multi-Skillia assistant and you want to specifically build it around a multi-skill system, you have to control this delicate balance between having your response selector being smart enough to control the narrative of the entire conversation with your user, and yet not digging deep into the details that are controlled by the smartness of your individual skills. Another ideas that we came up later on were the following. We needed our bot to be self-reflective. In what I mean is, a bot has to be able to understand why it said something. It has to be able to explain what is being said and why was something said by the social bot. Another idea was that we wanted to keep balance between not just talking about the user subject, but also being philosophical. What we found interesting from other social bots of the last year was that some of them managed to not only talk about particular subjects, but also to be philosophical. They could ask high-level questions. Like, for example, we can talk about travel, and then the social bot could ask questions like, but what this gives to your soul? Why? What do you experience during travel? How it changes you from before you managed to start the trip and after coming back to your home, coming back to where you started. And those things became interesting because they added depth to the conversation that is hard to model if you use poor goal-oriented techniques to build skills. It was also important to build persona into the system, because when you want to make conversation between your social bot or your AI assistant and a user interesting and engaging, it is not enough to just talk about some particular entities. You have to bring depth, and this depth is based on passions, on interests, on desires, on dreams of your interlocutor. And in this case, it means that we have to design the persona of a social bot around all those items, all those things, and use them during the conversations with the user. And one more observation was that we need to add some sort of humor. It's not like a trivial story like tell me a joke, but it's more like how we could use jokes and how we could integrate them into the fabric of the entire conversation so that they would be in the right time and in the right place for the user. I mean, all of those ideas, and with our Mikhail and mine experience and working on some startup in the conversational field prior to that, we decided to outline a vision for version 2.0, and turns out this vision was a bit more aggressive than we thought, and it actually is something that will expand into our next version of Alexa Price social bot, if we will be participating in it. And it's also something that helped us to outline the vision for architecture of our Multi-Skillia system platform. This is a crazy picture, this is a crazy scheme, but it actually makes a lot of sense when you start thinking about it. We laid out it in a few areas. One of them is conversational AI area, where you start with a conversational AI orchestrator and you build everything on top of it. You have a conversational history, you have profiles for users and maybe entire organizations, you have some knowledge graphs about users and maybe entire organizations, and you have some sort of user or you have some sort of interaction history and information about relations between the user and different kind of graphs, be it wall graph, domain graph, or your persona of your social board or your AI assistant. Then at the understanding and reasoning level, we wanted to support multi-intent goal-oriented skills. We wanted to extend our ability to do slot filling. And by the way, we incorporated our entity linking from the last year. We integrated it a lot, and we integrated it in such a way that we not only extract entities our current social bot, and actually now with DP, which is available at demo.deepavlov.ai, we connect those entities with a knowledge graph, so that we can actually have some grounding for what we're talking about and be able to maintain an understanding of entities that you talk about in a larger span of the conversation. We also wanted the system to be contextual, be empathetic, and we also wanted to enable development of open domain dialog systems. Again, I don't want to talk a lot about what we managed to achieve in Alexa Prize 4, but I'm extremely grateful to Denis Kuznetsov, who built the miracle of our dialog flow framework that our team used to build open domain skills for our platform. Then obviously on the skills level, if you're talking about not just social bots, but multi-Skillia assistants in general, this is all about laying out the foundation for bringing third-party skills into the system and having some sort of a skill store. And at last but not least, speaking of the dialog and skill management, it's all about having an expanded and more structured in-session memory, managing dialog flow, and have some sort of skill interoperability. And this, by the way, is a very tricky problem. Just to give you a comparison, if you look at Amazon Alexa or Yandex AI assistant, Alice, there is, I would say, very limited number of options for interoperability until very recent times. Skills in Amazon Alexa, they could not invoke each other. And only because entities in Amazon Alexa are actually connected to Amazon Knowledge Graph, those skills can actually share those entities with each other. And Amazon started a specific program for developers that enabled skill developers to share entities between each other. So, for example, you can order flowers for someone you are fallen in love with. And when you do that, you can specify a location for the destination. And then you might want to switch to another skill that would, I don't know, order pizza or some sweets and so on. And then you can reuse the same location data and pass that data to the next skill and have two of your different goals achieved without sharing the same information over and over to the system. On the learning and long-term memory, we wanted to work on multiple areas. For example, we wanted to introduce some sort of API orchestrators that would allow us to work with different data sources. We managed to achieve just limited success in this year, I would put it this way, and that while we have connected successfully Wikidata and Web and WikiHow and so on, we are yet to integrate other data sources and form a knowledge graph on top of all of those data items and make it available to the entire AI assistant or social bot. On the data interpretation level, we envisioned that we want to enable developers to build their own domain knowledge graphs, use vault knowledge graphs like Wikidata and maybe DBPAD and others, have some sort of editor for ontology and for individual items in the custom knowledge graphs. And also do a very delicate thing of mapping different kinds of data between different knowledge graphs to each other, which is super important when you want to do sharing of information between different knowledge graphs and enable seamless experience of conversation between the user and your AI assistant. On understanding and reasoning level, we wanted to extend our existing entity extraction technologies with relation extraction, which is actually something that one of our Google Summer of Code students actually working on this summer. And extract other kinds of things like ontology, properties and actions, which is very similar to how Palantir is working with different kinds of data in their information graph for their customers. At skills level, we envision that at some point there will be some sort of voice skill designer where you could design primitive skills by using just your voice, which is obviously a very complicated kind of thing, because in order to be able to describe the logic by your voice, users would have to have a huge cognitive load, but also the system would have to be very forgiving in the way how people would try to explain what they want. And we also envision that there should be some sort of graphical user interface for skill designer that would allow, first of all, business people, but later end users to design custom skills. And also thrilled to say that starting this summer, we started work on graphical user interface for our entire system. And it will have a skill designer for goal-oriented skills coming this fall. And it's also obviously about all the programmable skills and SDK. And again, our work on GoBot framework and DFF Dialog framework is something that where we put a lot of our attention into, and we will be happy to share this kind of functionality with our users. Finally, on the dialog and skill management level, we envision that we have to introduce semi-automated scenario generation based on what kind of scenarios people can bring to people. I mean, like one of the ideal ways how you can generate skills is where you can explain them in free language, and then the system would enable conversation on a given scenario. And this is also a huge undertaking. Another two kinds of ways how we envision to facilitate development of skills is automated skill generation. We've explored this area in this year, and we will continue exploring this area later this summer and this fall and winter. But this is also not a very simple thing to work on. And finally, speaking of learning and long-term memory, we envision that we will add support for business process to Dialog, which means where we can use robotic process automation to create level of abstraction and then build skills around this layer of abstraction to enable collaboration between users and business critical applications. Gosh, that's a really huge system. On assistance level, we expect that our AI assistants would enable proactive conversations, which means also something incredibly important and incredibly hard to implement. It's very easy to interrupt user, but being not just interruptive, but being proactive means that the system knows where it is the right time to begin its own lead of the conversation, and when it is the right time to just shut up and listen to what the user has to say. As I said before, one of the components and the key components of the system would be introduction of digital avatars or personas that will have depth and ability to understand user goals and have their own goals and interests, and be able to control dialogue based not on just skills, but also on the strategy that would be a mechanism for it to help users reach their goals, but also help those AI assistants to reach their own goals. And a simple example can be like this. Imagine that you have an AI assistant that you talk to, and it generally does whatever you want it to do, but it also might have an interest like in things like genetics, and how those genetics could influence and change the entire course of human civilization in the 21st century. Or it could have also passion for space exploration, and it could ask you questions about that and learn from you, and maybe learn something from the internet and then come back to you with the news. And this is very different from when you have a reactive system where you have to ask a question, the system will come up with a response. Because here there would be some drivers beyond the system that would encourage it to interrupt you at the right time and have a conversation with you about things that are important to it. We also want the system to be some sort of independent agent that could work on your behalf, maybe calling other people, like what Google introduced a few Google I/Os ago, and I think they still have not made this available to the general public. Or maybe work with your calendar, your mail, your other incoming information, and so on, and walking you behind. And we also envisioned that there should be some sort of a task engine that was actually able to do all of those tasks on your behalf and be controllable, so they could look at it and see what's happening and make necessary changes to the system. And all of those AI assistants, they have to be available through different kinds of user interfaces. Obviously, there has to be support for text-based user experience, and that's something that we made available through Telegram and other user experiences for more than 2 years now. And it's voice-only UX. For that, for example, we introduced a connection of NeMo coming from NVIDIA as our mechanism for ASR and TTS, and we integrated that with our DeepPavlov agents-based DP, our open source multi-Skillia assistant. But there are also a place for visual UX, because like 90% of information that people interact with is coming through the eyes, so we have to support that as well. And at least but not last, there's multi-modal user experience. Like more than a decade ago, I recall during my internship at Microsoft Research, we had an AI assistant that was able to recognize when people talk to it, because it had a webcam, and it used that webcam feed to know when users are actually looking at it when talk to it. And this is a potentially very big thing. Today, when we interact with our AI assistants at homes and at work and in transport, we have to activate them through the wake-up word, Alexa, Alisa, and so on and so forth. But Alexa, cancel. But in reality, we don't do that always. Yes, sometimes we do ask people by name, but we do it just to maybe initiate the conversation. And then we use visual clues. We use body language to recognize that we are still in the conversation with a particular person. And this is a very promising and very important direction for providing a native user experience for interaction between users and AI assistants. Okay, and at last but not least, we have lots of different channels through which users should be able to interact with their AI assistants built on top of our DeepPavlov conversational AI stack. It could be web applications, native applications, messaging channels, skills for existing consumer AI assistants. And it's all about equipment, smart home equipment, earbuds like Amazon Echo earbuds, or smart glasses. I still think I have some of them somewhere here. Or smart speakers and phones and tablets and PCs and laptops and so on. So when you look at all of those things, you realize that the iceberg of conversational AI is really huge. And while we think that just a few areas where we need improvements, it's not so. All of these areas needs a lot of work under the hood to make a great user experience for people who work and interact with AI assistants. Okay, some of the things we decided to invest into for version 4 2.0 are highlighted here in yellow. And I would say that we've done some great progress in slot filling in open domain conversation. And because of slot filling enabled with entity linking and so on, we also expanded on entity extraction thing. We introduced use of our own mechanism working with world graph based on Wikidata. And so, as I said before, we integrated Wikidata and WikiHow into our system. But a lot of other things here are still something that we are working on. And when I was talking about the vision for 2.0, I wasn't talking about vision 2.0 for entire AI assistant for Alexa Prize 4, but also for 2.0 or what we should do after that. And this is a really multi-year plan. It will take a long time for us to make a significant progress in all these areas, but just to give you some reason for optimism, let me highlight a few areas where we're also doing progress these days. Graphical user interface for skill designer, relation extraction, there will be some work on domain graphs hopefully later this year. And by the way, we have some more work on different kinds of annotators and topic classifiers. We have our speech function classifier, and my God, we have a combined classification system that allows us to actually save some resources in identifying topics and dialog and so on. We've made some great work with user profiling and user knowledge graph, and we will have some more work in the coming months, in the summer, in the fall, and so on. And we put some work into bot persona in our system. So it was a great progress we've made since last September, but as you can see, we're just getting started. Here, I would like to highlight the topics of the conversation that we will have with you in the coming several community calls. We will start with topics, continue with knowledge graphs, and dive specifically into world graph, user graph, and bot graph. And then we will talk about how to balance between generative models and topic and entity-based templates. There are lots of different learnings we made over the last year and a half. And I'm not going to talk about all of this stuff today. So this will be subject for the next community calls. And right now, if you have any questions, I will be happy to address them. Let me now enable you to unmute yourself. I think it's going to be fine. And you can also use chat if you like. So if you have any questions, feel free to ask.
Do you have controllable text generation by keywords, for example?
We have something like that, but it's not yet available in our general library or our Multi-Skillia system platform. We experimented with Parlay in the last half of a year, and I hope we will be able to provide a deep dive into this and other learnings from Alexa Prize for later this year. But right now, I don't have anything more to say.
Okay, thank you.
Thank you for your question. If there are any GSOC students here, feel free to ask questions as well. It's going to be really fun. Sasha, what did you want to say?
I'm not sure yet.
Okay. Nicholas, if you have any questions, feel free to ask. I know that that's a lot of things for you, especially given that you work on like one of the components of the system. But I'm thrilled to know what kind of questions you have based on what you just heard.
Yeah, it was really interesting. Thanks a lot for sharing those insights. I was wondering on the, like, right now what we're doing with the chatbots on the speech side, we're not taking into account at all the emotion of people when they speak and so on, right? Because we just use like TTS and so on, and then we get like the text, right? So a lot of details that people have in their intonation and so on get lost, don't they?
Absolutely, yes. Speaking of goal-oriented system, that kind of information is usually lost. And when we were designing our open domain system with the Dream social bot for Alexa Prize 3 and so on, we actually made it top priority for us to bring those annotations for each moment, for each conversation turn. So all of the plethora of information we have about the system, about the user, and so on is available to all skills. But yes, for goal-oriented skills, this is usually not available. But if people want to build a goal-oriented skill using Gobot framework actually allows people to add skills in here. So we can easily add a Gobot skill into the system. And one of our other interns this year, he's building a user interface to visually design those skills. And the thing is, because Gobot is one of the skills in the architecture, it can potentially access all of those kinds of annotations. But for the time being, by the way, how it is designed right now, the proxy component that hosts Gobot skills within the system, users have to manually process all of that information, and this kind of information is not used by the Dialog policy of this Gobot-based skills for the time being. But if you have any kind of ideas and so on, it would be fantastic if you could explore them after your main assignment with GSOC. Does it make sense?
Makes sense. Thanks.
Thank you very much. Does anybody else have any questions?
What approaches do you use for knowledge graph? Do you use relation extraction for unusual types of entities, like not in organization or persons?
Great question. So for the time being, the only component we have right now is entity relation. Sorry, entity linking. Okay, wait a moment. So where is Zoom? Let me share once again. Where is Zoom? Here we go. Share. PowerPoint slide deck. Here we go. So when you zoom out, so what we have right now is entity extraction and entity linking. So every time we extract an entity from user utterance, we also connect it to the knowledge graph. We use Wikidata as our knowledge graph. And for each entity, we identify also its type based on what Wikidata thinks about this item. So this helps us to bridge the gap where we don't have to specifically design slot filling in a traditional way how you do it in goal-oriented systems, because once we matched entity to a knowledge graph, we can by design get its category or get its kind from the system. And this has some interesting specifics. We have two different versions of entity extraction or entity linking, more specifically. The one of them is based on our classic NER, which only has support for people, organizations, and locations. But we have another version of named entity recognition system that actually just recognizes if there is an entity or there is no entity. And it is trained on a different data set, LSQuad, and it allows us to find way more kinds of entities from the text than the traditional named entity recognition component we have. And this allows us to extract a lot of different types of data and knows that those types of data are coming from Wikidata. Speaking of relation extraction, now relation extraction is something that is a subject for our development and something that we hope to get integrated into library by the end of summer. And we haven't got fully working bits yet, so we haven't used this kind of technology yet. But this is in under active development, and we are looking forward for seeing it in the product.
Cool, thank you.
Sure. If you feel that there is a need for things like property extraction or action extraction, let us know. It's also some of the very interesting areas of investment into the product. So for the time being, we decided to go with relation extraction, but that's just one of the things.
Yeah, there is another topic like event extraction. So basically, event is is a small knowledge graph itself, because it involves in this location and people and other things. So event is a small knowledge graph itself. So it's a very complex thing.
Yeah, I absolutely know what you're talking about. I had some kind of experience like this at Yandex, for example, where we had to extract structured information from emails and build this kind of small knowledge graphs about what's happening within the emails. It's a challenging task anyway, but it's also doable. And well, I would not promise that we are going to work on this in a more structured form this year. It's something that we have also on our radar. But yeah, it's a very promising direction.
Cool, thanks.
Thank you very much for your questions. Okay, so I think it's going to be a wrap up for today. As I said before, we actually have lots of different subjects to talk about next time. Next time we will start talking about topics and how we can extend our system by introducing topics into the system. And come next last Thursday of the month to continue this conversation.